Okay, so here's the one where if it's just x.
Okay, so we can basically use the same method as before to find the areas of our squares.
Mm-hmm.
So marking out this length as being x makes these lengths each x over 2.
Uh-huh.
And their area is x squared over 4 each. Then I called this length y, this length of our smaller square. And again, that creates a Pythagorean right triangle. Creates a right triangle. This length is now x. This is x over 2 plus y. And this is 2y.
Alright.
So we can use the Pythagorean theorem again. We get x over 2 plus y, quantity squared, plus 2y, quantity squared, equals x squared. Simplifying that, we get x squared over 4 plus xy. So we get x over 2 times y times 2.
Yep.
Plus y squared. And then plus 4y squared. And again, since this x squared over 4 was in fourths, I put x squared as 4x squared over 4 because I wanted to do the same thing as before.
Alright.
The y squared and the 4y squared make 5y squared plus xy. Subtracting 4x squared over 4 from both sides, we get minus 3x squared over 4 equals 0. And now the difference between the case where this was 5 and this is x is we can't divide by 5 anymore because not all the terms have a 5 in them.
Ah, okay, good. Good, but actually, interestingly, a 5 appeared sort of naturally also.
Yes.
Alright, so that's interesting.
So we can use the quadratic formula again. This time we get y equals minus x because we're looking at, we have y as our unknown. X being unknown doesn't really matter because we're not trying to solve for it.
Okay.
So x is included in our coefficient, minus x, plus or minus the square root of x squared, and now we had minus the quantity 4 times 3x, minus 3x squared over 4 times 5.
Mm-hmm.
This simplifies to minus 3x squared times 5, so we had minus 15x squared, so it's a plus 15x squared.
Yep.
And this a coefficient is 5, so we get over 10.
Okay.
So these x squared and 15x squared simplify to 16x squared, which simplifies to 4x. And we get x squared, or minus x squared plus or minus 4x.
Minus x plus or minus 4x.
Yeah.
Yep.
Over 10.
Mm-hmm.
And again, we have to choose the minus x plus 4x to make it always positive.
Yep. Okay.
And so we get 3x over 10 as our final length for y. That makes our area for each of these 9x squared over 100. So adding them together makes 9x squared over 50. And I also added these two together to get x squared over 2. And we had to multiply by 25 over 25 to get a common denominator.
Okay.
So we had 25x over 50 plus 9x over 50. So we get 34x squared over 50. And then we can divide by 2 to get 17x squared over 25.
Okay.
That's our final formula for any x here.
Nice. And it checks out actually because when x was 5,
We got,
we got
17 times 25 divided by 25, which is just 17.
Okay, super. I want to take one last look at this equation,
Okay.
which is 5y squared
5y squared
plus xy, on screen, yeah.
Yep. Minus 3x squared over 4. That equals 0.
And you found solutions to that were
X or y equals x
minus
plus or
x plus or minus
4x over 10.
over over 10.
Okay.
And that was, let's see, that was 3x over 10
And
and
minus 5x over 10.
So minus x
Minus
over
x.
2.
Yep.
Okay, let's take a look at that equation for our last video.